Thanks, Chris. So, getting down more to the nitty-gritty about what tools we can use to achieve better lighting outcomes, lighting energy and carbon outcomes. So what can new technology achieve? Starting with a bit of a timeline about digital to analog to digital lighting transformation. And a bit like digital photography, a bit like digital music, there's been an awful lot of change. There's been a massive transformation over the years, in recent years, in lighting technology. So this is a bit of a snapshot of the past 120 years. Pretty much for a century, we had a range of traditional technologies: incandescent lamps, mercury vapor, linear fluorescent, high pressure sodium, and metal halide of, let's say, analog technologies. And a lot of people, well, these are just names, but typically things like this. We're all familiar with the conventional residential light bulb, of course, and the fluorescent tube. But many of the more specialty light sources were things like high pressure sodium for flood lighting, street lighting, mercury vapor for industrial commercial premises, looking as conventional glass bulbs with high pressure gas discharge technology inside. So they have moved on, and in this section here, from about 20 so years ago, we said these lamps have been improved. Linear fluorescent, compact fluorescent joined us about 20 odd years ago, but the traditional lamps did move forward. The technology improved, mercury levels got lower, and color performance improved, and they generally gave better service and with higher luminous efficacy of the lamps, in other words, more energy efficiency. So it wasn't static. Things moved forward, but it was an incremental expansion and improvement. It wasn't step change. But then LED came along. We said LED uptake in New Zealand from about 10 years or so ago. LED was invented before that and was introduced before that. But in terms of that sort of critical mass, center of gravity of uptake among buildings, commercial buildings and private buildings around us, it was really only 10 years ago that critical mass was achieved in New Zealand and moved forward. So that was all happening there, which meant potentially, and in reality, some good things for energy efficiency. But also there were some problems. Some LEDs, the quality of light wasn't so good. In this technology under incandescent, we had halogen, which is very good for color, very good for feel and sparkle and display type purposes in retail, particularly higher end retail and in residential homes. So we actually went backwards a little bit in terms of quality of light. Yes, we had excellent energy efficiency, energy performance, but the actual feel, comfort and vibrancy, say, of the premises, in some cases went backwards. So that wasn't so good. In more recent times, in the last handful of years, LED plus controls coming through. Controls can be quite complex, they can be simple, and when we say controls, a lot of these things relate to plug-in devices that go into outdoor luminaires, which can be simple controls like photocells or more fancy radio controls. And there's been a range of sockets which have emerged, which can go onto various light fittings, which are really what I call the USB for luminaires light fittings. This is an American sourced one. This is a general, more international one called Zaga Book 18. These are called NEMA sockets, which many of you, if you're involved in street lighting or public lighting, would have heard of. So they've been coming through, and New Zealand has been particularly active in this area, and we're actually, in my belief, we're world class in terms of particularly outdoor lighting controls, in terms of uptake in that area. But moving on, from about now and moving forward, really what we're looking at is as viable options. When I say viable, I mean reliable, economic, readily available, and not just leading edge type projects. LED controls and sensors. And those sensors can sense occupancy, can sense whether a room is being used, and can actually provide two-way communication. It's not just telling the luminaire, the light fitting, that turn yourself on, move to this level. dim up, dim down. It's about two-way communication, data monitoring, condition monitoring, preemptive maintenance monitoring, and data logging are now very much achievable. So we're not going to go into the details of all of that. There's a whole list of acronyms out there, DALI, ZAGA, and a range of other ones that lighting specialists bandy around. So I'm trying to stay away from those sorts of terms, but just be aware that there is an awful lot happening and continues to happen in this area. And really what we're trying to focus on today is give some feel for the relative economics, the reliability, and how one can implement these controls without undue complexity. So, once again, the analog to digital transformation, disruptive LEDs. Disruptive technologies of any sort can completely upend an industry, both for producers, consumers, and others in the supply chain, and that certainly happened with LED. I don't really need to dwell too much on that, but everything has changed. And now for new lighting supplied in New Zealand, we're about 99% market saturation with LED. There's very, very few still, analog light sources supplied these days. And also disruptive intelligent lighting systems. There's lots of different terminology used around lighting systems, lighting controls. We hear intelligent, we hear IoT, Internet of Things and the like, and there's really no prescribed names to these things, and sometimes lighting specialists use different ones, as I do, from time to time to suit the various market. But intelligent means some degree of sensing, some degree of changing their behavior and their state. And it's not just about dimming now. It's not just about moving the light levels up and down. It's about color change from warm light to cool light, and it can be sector-based decision making by area. And then we have something, here's a little bit left of center, one would think, discovery of the third photoreceptor in the eye. Less than 20 years ago, researchers at Oxford University in the UK discovered that there was another photoreceptor in the human eye. The first two are called rods and cones. Some of you may be well aware of these things, which detected visible light and determined our human response to that type of light, its color temperature, its levels, and how we reacted and felt because of that. But the third photoreceptor in the eye is about not necessarily just about visible light, but non-visible light, and how it can actually affect our rhythms, our well-being, and our sense of comfort. And I know very little about the physics of all of that, so I'm not going to embarrass myself by going further than that, but this was absolutely a step change breakthrough not so long ago. And what's really come from that discovery is what Chris mentioned earlier, human-centric lighting, integrative lighting. A lot of research is happening on how that can affect human behavior, human feel, etc., and how lighting control systems can actually deliver lighting more attuned to the needs of the occupants, be they office workers at home or in a restaurant, etc., etc. Big challenges and opportunities for all stakeholders. Upending of an industry, upending of a stakeholder supply chain means everything changes. And also from the consumer point of view, it's about how one procures lighting, specifies it, manages it, controls it, funds it, finances it, etc. So for all stakeholders, implications for the lighting industry. Previously, the large established companies that might have been the internationally dominant parties in a certain area, metal halide lighting, fluorescent lighting, suddenly that industry vanishes almost overnight, and that's exactly what happens. Newcomers come in, create new niches and have prospered in that area. So many of the brands that your suppliers might be talking to you about or your advisors might be talking to you about will be unrecognizable to you if you're a property manager. That's not a bad thing. That's the way it is. And many of the large established players and small established players have had to really transform themselves into being a digital industry rather than an analog industry. Implications for consumers, predominantly around purchasing, procurement, how contracts are managed, how contracts are set up, and how lighting is financed. More about this as we go on, but certainly the implications for consumers is quite in-depth. And conceptual shifts are needed for all stakeholders. Really need to think from ground zero, from a clean sheet of paper, about how we go ahead with implementing better lighting, which will give us, of course, better energy performance, better carbon performance, but also really good lighting performance. So the building, the infrastructure is fit for purpose, and is kept that way. It's not a snapshot. It's not a first-off thing. It's not where you put all your effort into the capital project and say, hey, we've built a good building, we've built a good pathway or stretch of road or whatever. That needs to be kept up as time goes on. And just like computer systems, IT systems, we know that when we've got it set up and it's running well, it's not going to stay that way. We need to keep working on it to keep it fit for purpose, and also to grab the upgrades which are possible as technology progresses. So, a bit of an overview here. The transformation in lighting is more than just vision. There's added value aspects here that we can bring to bear. And this is a timeline along here from, let's say, the 1980s to 20 years' time, 2040-ish. And this is about value, not just financial value, but not just economic value, but also value as user value and user comfort, et cetera, et cetera. So energy efficiency, of course, is where we started out. And compact fluorescent came in about 20-something years ago, and that was the emphasis. Rightly so at the time. Then LED lighting came along. We've got tunable, we've got dynamic, with the ability to dim up, to adapt up, and to dim down. And that was a groundswell change. Then we're moving on. Now, pretty much where we're at, intelligent lighting systems are now economic, practical, and feasible. And we get this concept called Internet of Things come in. I try and stay away from that term. It's a bit faddish, but I think most of us know what it means is devices talking to each other, and lighting are connected devices which can talk to each other and talk to other aspects of a system, such as a building control system, data logging, monitoring, et cetera, et cetera. Then what happens from there? Circular economy comes in. We speak more about this as time goes through in this presentation, but effectively what we're talking about is serviceable, upgradient, and upgradable lighting systems, luminaires, how they can be maintained in a properly eco-conscious way and not thrown away, the whole thing thrown away when one small element or component goes wrong. And finally, human-centric lighting, as Chris has introduced us to. It's about using all of these smart controls and connectivity and control systems to provide better outcomes for humans, user well-being. That's a pretty elastic concept, whatever that means, but we generally know it when it's not there. We can't quite articulate it when it is there or explain it, but when it's not right, we generally know that it's not right. So just concluding this, the elements were energy efficiency was where the big focus is, and as we go along our timeline, there's 1980s, we're about 2030 to maybe 2030-ish here. Quality of life, light is very, very important. And of course, it's about energy efficiency. That's a given now. That comes along pretty much with everything. But our focus is no longer singular, and it's multiple factors. That makes life a bit more complicated. Procurement's a bit more complicated. But the value package overall is getting towards to be a heck of a lot better than where it has come from. A brief introduction to lamps and luminaires, and I'm using this term without really qualifying it. A luminaire is the technical name for a light fitting or a lighting fixture, and that's generally what's used in standards work now and in commercial technical applications. And a lamp is what a layperson might call a bulb, but they're not all bulbs. There's different shapes and different forms. So essentially, talking about retrofit LED lamps is aftermarket retrofits, and then about dedicated LED luminaires in their various forms. And to cut a long story short, essentially, this is where it's at. This is much less about where it's at. Retrofit LED lamps do have a purpose. They can provide convenience. They can provide a quick update for an existing building or an existing system, and that can deliver good value for money, and energy and lower carbon updates. But generally speaking, if one is starting from scratch for a new development or a new project, dedicated LED luminaires provide better long-term value for money, better long-term energy and carbon outcomes. So in this presentation, we're concentrating on optimized LED luminaires. And when I say optimized, I mean electrically optimized, electronically optimized, photometrically, which is the term for the light distribution, the light that actually comes out of the product and how it fits with the application, and visual comfort, glare, in other words. So we're flipping over these, but they do exist. They are compromised in terms of the physical attributes. These have quite a bit of electronics inside them, which are heat managed with heat sinks and the like. And many of these products have very complex electronics. I've got a control gear pack here, which is the electronics which drives the lamp, the bulb. And I love this at the back because it's got clear, and it just shows the level of computer power which is in these devices. It's jam-packed with computing horsepower. And when a manufacturer is trying to cram that horsepower into very small devices like a general service lamp and a halogen replacement lamp here, there has to be compromises physically, economically, and at various price points. So bear in mind, they do have their place, and but essentially, if one has the ability to work on a, let's say, an optimized project, this is where your efforts would be invested. Final slide in this session, in this presentation part. Introduction to simple and smart controls. And that might sound a little bit of an oxymoron, a little bit of a contradiction. How can they be simple? How can they be smart? And the answer to that is, the more smart they get, the more simple they get to implement. And it's a bit like, remember our computer printers. When we set up an office printer at home, we had to load the software for the printer, we had to load it into our PC, we had to then get them to talk to each other and jiggle things around until it all happened. These days it just happens. We plug them in and all happens behind the scenes. It's very similar with lighting control systems. There's an awful lot of intelligence happening behind the scenes to make the human interface simpler rather than more complex. We've evolved from complex control systems, I'm speaking sort of commercial offices now, but as well as homes, I guess, to more simple retrofit devices. It used to be that one needed really specialist advice, lighting engineers, IT systems people, complex commissioning to get controls up and running properly. But a lot of these new systems and devices are actually self-commissioning and self-setting up. So wireless is a predominant retrofit solution, not needing cables, not needing to rewire. It's a very important thing, particularly for a retrofit. And also, in terms of the wireless technologies, there's a range of different information technology protocols and standards that are being used. Bluetooth is a common one that crops up, seems to be growing quite strongly. There are many others, so just be aware of that. And my diagrams here essentially show that we have luminaires light fittings with various sockets, which devices can go in the top and underneath. That's a street light type fitting with a sensor here, with industrial type light fitting with a sensor here. And this is a range of various little plug-in devices. I've got some here. Sensors used to be really quite big and chunky, about that size there, and now can be very much smaller. These are called Zaga 18 sensors. I won't mention what that name means, it's a very long story, but they're getting smaller and smaller, and we see a few of them here with lots of different sensing capabilities within them. The obvious one is human sensing, turn the lights on, turn the lights up when a human gets in within range in a warehouse or something, or they can be for a range of other types of sensors which communicate with the light fitting. And over here we have smartphones, because tablets and smartphones are becoming a very common interface device. We don't need a special one. We don't need one made by a lighting manufacturer, because you've already got it in your pocket. Download the app, dial it up, and change the color, change the level of light, or change the physical area where the light is being put into in your home. So major strides have happened there. Prices are coming down, down, down. Functionality is going up, 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 just like most things in the computer world. They do require a bit of knowledge to procure and to implement, but it's not scary stuff, and vast changes have happened for the better in that area. So, a term that crops up with the use of control systems, rather than, we spoke a little bit about the technology and the hardware, this is about using control systems, and it's important to make that distinction. Adaptive lighting control is a term that's frequently used. We all know what dimming is. It means bringing the light down from bright to less bright, but that's in one direction. That's taking something away. Remember that dimming could be upwards as well, but it doesn't sound right to call it dimming. So adaptive lighting is the term that has emerged in that area for energy and carbon savings. And we have 4 scenarios here to speak about. 1, 2, 3, 4. And this is the old school, full on, all the time, and with no savings. So we have a time scale here, 24-hour clock, say, or it could be from darkness if it's security lighted, coming on at 6 p.m, going off at 6 a.m, and here we have the light level, full on, for all of the hours of darkness. If that was an office light, it would be on. People come in the morning, 7:30, 8 o'clock, whatever, and then 6 o'clock they come off. So how can we do things better? We could have scheduled switch on, and then off-peak dimming adaptive here. So essentially what we've got, there's peak load, there's let's say an evening peak load, there's a morning peak load, and from midnight through to dawn, if no one's in the space, no one's in a building, no one's on a pathway, no one's in a road, why the heck are we lighting it? Turn it off. Obvious, things our grandmother told us, but somehow we come full circle. So there are the savings, proportional to the area under the curve, energy savings, carbon savings, operationally in that area. But we don't have to turn them off completely. We could dim them down, once again, for the hours when the lighting isn't needed, and there's our savings area in there. Now, getting more to the nitty-gritty with more complex stuff with sensor control. And what we're seeing in these blips here going up and down is something like an occupancy sensor going on and off. It might be in a boardroom, it might be a security light outside in a car park when people are leaving, it could be a pathway, cycleway, whatever. And this is a combination of the scheduled half output. In other words, we're mimicking that there, but we're overlaying it with a sensor control which turns them on and off. So at the end of a period, what we do when designing for controls, we make an estimate. We make a probability estimate of what this is going to be. So we work out what our intended energy and carbon outcomes are going to be, but we've got to calibrate that against actual triggering at the end of a period, end of a month, end of a year, whatever. So this graphic depiction comes up again and again, and it's a very good way of coming to grips with what our savings potential can be. Rather than numbers and figures, which eyes tend to glaze over, drawing a graph is a very appropriate way to go. So adaptive lighting control in action. In principle, it's really simple. Adapt light levels and switching patterns to mimic demand patterns. So what we've got here is, say, a pathway or a walkway, something like that. We've got time along here, time of the day, and we've got our light levels here from 0 to 100%. And this red dotted line is, let's say, is our traffic flow. It could be the traffic, the number of people moving in and out of a boardroom, in and out of an office area. It could be a pathway, cycleway, roadway, whatever. So here in this red diagram, this is the history, this is what's happened over the course of a given day. We've got a peak load here. At the beginning of the period, we've got a peak load at the end of the period, but it fades away where our activity levels are much less. So what do? Of course, pretty obvious, we take our dimming control and we take a big bite out of there where we turn the light levels down to match the levels of demand as appropriate, and we save that much. That's pretty crude. We could have taken a double step there if we were more ambitious. But generally speaking, when we have fewer people in an area, let's say on a pathway, walkway, roadway, car park, outdoor car park, the light levels are proportional to the traffic, the amount of activity that goes on there. So when activity is down, we can bring our light levels down and remain in compliance with the design standards for safety, because after all, for many applications, why we light? Why do we light at all? For safety reasons. And we don't want to forget. Energy efficiency is important, carbon's important, but safety is obviously an early priority. So that's all from me on that section. And Chris is going to continue on some practical applications.